Hello, ladies and gentlemen. This question is actually a homework question from a Singapore student. Let's take a look. So, part A is to find out the coordinates of point B. Now, notice that point B is actually the point of intersection between the curve as well as the line AB. So, therefore, when you want to find the point of intersection, you will have to do a simultaneous equation. So, for part A, I'll write down the two equations, xy plus 3 equals to 0. I'll first call this equation 1. Second equation, it's from this line equation. Then I will be making y the subject, so I'll move the 2x to another side, which gives me negative 2x minus 5, and I'll call this equation 2. So then I'll substitute equation 2 into equation 1. X times negative 2x minus 5 plus 3 equals to 0. Expand it, you will get negative 2x squared minus 5x plus 3 equals to 0. Now, when I do factorization, I will usually prefer my coefficient x squared to be positive. So I'll multiply negative 1 on both sides. So this becomes a plus 5x and this minus 3 equals to 0. Then I'll start my factorization. Now, I know that many of you are able to do factorization with the help of your calculator. So you can do that, of course, but you should also master the skill of factorization without using the calculator. Factors of 2x squared is 2x and x. Factors of 3, it is 1 and 3 because it's a prime number. And to get positive 5x, this should be positive 6x minus 1x. So with that, your x coordinate is either half or negative 3. So actually, the curve and the line will have 2 points of intersection, just that now in part A, to find the coordinates of B, you will focus on the x coordinates that give you positive value, because point B is located at the positive region of the x-axis. So with that, I'll be rejecting x equals to negative 3 because x must be more than 0. So you need to find the full coordinates when x is equal to half. Sub into equation number 2, negative 2 times half minus 5, that will give you negative 6. So therefore, the coordinates of point B will be half comma negative 6. Now let me write that down so that we can visualize the coordinates better. Now also at the same time, let me just write down the coordinates of A, which is 2.5, comma 0, which is already given in the question, just as not labeled. Now that's my answer for part A. Let's move on to part B. Now part B is the area of the shaded region, and give your answer in some specific form. Now notice that this whole shaded region is actually area below the x-axis. Whenever you are dealing with area below the x-axis, you will notice that you have to use some modulus in your integration. I'll talk more about it later. So you can portion this area of shaded region to two parts first. You should be able to see that I'm highlighting a right angle triangle, where this right angle triangle, you can just use half times base times height. So with that, part B, area of shaded region. For the first triangle, you will have half times base times height. So let me just label it for you. This is the height, the base, and this hypotenuse here, right angle. Now let's talk about the base. The distance here from A to O, it's 2.5 units. From O to point B here, not exactly point B, but you know that this is half units. So therefore, in total, the length here is 2.5 plus half. That will give you 3 units. And how about the height? The B coordinates, Y coordinates here, it's negative 6. So this height here is also 6 units. So that is the red triangle. Now, how about the next part here? The green region. Now, this green region, too bad, you have to use integration because it's bounded by a curve BC. So with that, from B to C is half to 1. So your integration, upper limit is 1, lower limit will be half. And you're integrating the curve here, BC, which is made up of this equation. Now for that, let me rearrange. For y to be the subject, there will be y equals to negative 3 over x. So you are integrating negative 3 over x with respect to x. Now bear in mind that this green region here, because it's below the x-axis, so you will need a modular sign. Now what's better is that you can actually get rid of this negative sign because modulus is making everything positive. So instead of using modulus, what you can do is also getting rid of the negative sign, 3 over x, then you no longer need the modulus sign. Now first part, the area of triangle, you can actually simplify it to 9. So let's start our integration. 3 is just a coefficient, so you don't actually need to be bothered by it when you integrate. This will be 3 ln x, where you need to substitute your x to be 1 and half respectively. So you have 9 plus 3 bracket ln 1, 3 ln 1 minus ln half. So with that, simplify it further. Ln 1 is actually 0. So 3 times 0 will give you 0. 3 times negative ln half. Now before I multiply, I actually know that negative ln half, okay, it's going to be multiplied by 3. So 3 negative ln 2 power negative 1. So I know that over here, it will give me negative 3 ln 2 power negative 1. Now notice that the form that they want me to change to, it's a coefficient 1 for the ln term. So therefore, I must get rid of this negative 3 so that the coefficient of ln to be 1. So it will be 9 plus this negative 3, it can become a power. So it will be ln 2 power negative 3 times negative 1, that gives me 3. So the answer for part B is 9 plus ln 8. So this actually gives you positive integer p, which is 9, positive integer q, which is 8. That's my part B. Now let's take a look at part C. Find the equation of normal at point C. Let's zoom into point C. Now point C, I know that is directly below point D. Then I know that the coordinates of point C, x coordinates will be 1, but I do not know the y coordinates. You can simply substitute x equals to 1 here into the curve because C is a point on the curve. Substitute x equals to 1 here to find the y coordinate. So negative 3 over 1, that will give you negative 3. So the y coordinates of C is actually negative 3. So how does that help me? You want to find the equation of normal. Now what is normal actually? So when you want to find normal, it's actually related to tangent. So let's say you have point C here. The black line that I just draw on the screen is what we call tangent. Now, the question actually asks for a gradient. So that's the gradient of normal. So the gradient is actually a 90-degree relationship with the tangent. So this is a normal line. Now, if we want to find the equation, we will first need to know the gradient. But how do we know the gradient of normal? We will need the gradient of tangent. How do we know the gradient of tangent? You need differentiation. So I have the curve y equals to negative 3 over x. I will need to do dy dx. So this case is negative 3x power negative 1. So when I do differentiation, coefficient stays, power go to the front. Negative 3 times negative 1 gives me 3, and power deducted by 1. So that gives me negative 2. Now, in particularly, I'm actually looking for the gradient of normal when c is equals to 1. So therefore, I'm looking at dy dx, x equals to 1. Sub in x equals to 1, you will actually get the gradient of tangent to be 3. As what I've said, we want gradient of normal. So then gradient of normal, because we know the relationship of m1 times m2 equals to negative 1. So we know that gradient of normal 3. Now to find the equation of the normal, you have two ways. Y minus y1 equals to mx minus the x1. You should know this equation from your A math. Or you can also use y equals to mx plus c. But the first method is better. So you can just simply plug in the coordinates of point C, which the y coordinate is -3, the gradient is -1/3, the x coordinate is 1. Rearrange, expand it, will be negative y equals to -1/3x minus 8/3, and this is my answer in part C. If this explanation video is helpful for you, please subscribe to my channel. Thank you.